No, put my camera.
Will you tell me when to start talking? Shall I go, Josh? Good afternoon, I think, for most of us. Good morning in the US. Welcome to our session, one of the first in the parallel sessions on fertility. It's wonderful to have you with us in a great session. My name is Murray Leibrand. I'm one of the co-chairs of this particular panel on population poverty and inequality. And our moderator is Jocelyn Finley, also one of the panel members in the session. And we look forward to a engaged session. We've got some really lovely papers. We have 4 papers on the program, one on fertility stalls in sub-Saharan Africa, one on the colonial origins of fertility, one on climate and fertility, and then one on how missing men lead to missing women. It seems that the first paper, I should have said, sorry, is from Ken Hartgen from ETH in Zurich. The paper on colonial origins is Roland Angu from University of Ottawa. The climate and fertility was Letitia Martelletto from the University of Texas at Austin. And then how missing men lead to missing women is from Joshua Wilde from the Max Planck Institute for Demographic Research. Letitia is not with us, it seems, today. So we have 3 papers, and the flow of the session will be as follows. This is the introduction. And then, as you know, you've suffered through the rigors of producing a video. We will play the videos then sequentially. I will just briefly introduce the speaker, which are very briefly before each video. Then we will have discussion of the papers. We've lined up discussion for the presenters to discuss each other's papers, with Letitia dropping out. That might turn out to be difficult she was going to discuss Joshua's paper, but perhaps Jocelyn and myself can say something about that paper. And then we will open up for discussion that you would have inputted. We hope you'll be very lively on the Q&A. In the Q&A chat, please. Table your questions and comments in the chat as we proceed. The presenters can answer in the Q&A chat. Like each other's questions. If you think it's a really good question, like it, because then it moves to the top. And once our discussants have had their commentary, we will then table those Q&A inputs for discussion. And you can even put up your hand and ask to speak during that session. So we encourage your full participation. We know that we're somewhat limited, but let's make the most of this session if we can. So thank you very much. And without further ado, then let's move to the first paper, which is is Ken Hartigan speaking about the fertility stalls in sub-Saharan Africa. Thank you. So if we can play that presentation. I'm not seeing the presentation. Is it just me?
I don't see it either, no.
Sorry, I'm having my first
Okay,
incident.
thanks. Thank you, Paul.
We saw it before, Paul.
Yeah.
It flashed up and then...
Let's see.
That looks hopeful. We're not hearing it though.
Ah, that's what I thought. Sorry. Well,
Yeah.
that's the problem.
Thanks everyone for your patience. This is our first go at this.
Here we go.
Welcome everybody. My name is Ken Hartgen, and the paper I'm going to present is called Slowdowns of Fertility Decline. When should we call it a fertility stall? So we changed the title a little bit, which is joint work with Isabel Günther, Michael Grimm, and Stefan Klaasen. For a very long time, it has been assumed that the demographic transition is a stylized fact, which means that sooner or later all countries will experience a transition from high fertility levels to fertility at the replacement level. However, none of the sub-Saharan African countries has completed the fertility transition except South Africa and Mauritius, but even in these two countries, fertility varies greatly across socioeconomic groups. While some countries in sub-Saharan Africa have not even started fertility transition yet, for example, Chad, many have seen declines in fertility rates that came to a standstill, and some countries have even experienced a reversal of the trend, for example, Ghana and Nigeria. And these latter phenomena I refer to as fertility stalls. The phenomenon of fertility stalls in sub-Saharan Africa has recently received much attention in the literature, yet without arriving at clear-cut conclusions, and there's still an ongoing debate about how to measure such a fertility stall. So the scope of our study is that we try to make two contributions to the academic literature and to the policy debate behind it. First, we test the robustness of previous findings by comparing alternative definitions against each other and by including countries outside of Africa and the most recent survey years into the analysis. Second, we propose a new definition of a fertility stall, which is based on the economic theory of the demographic transition. In doing so, we argue that a conditional fertility stall refers to a situation in which a country does not see any changes in fertility rates despite improvements in child mortality, income, and mother's education. And this is based on the assumption that these three forces are important preconditions for fertility to decline. Or to put it differently, we argue that as long as child mortality is high and female education as well as income are low, the socioeconomic circumstances are unfavorable for a substantial and long-lasting decline in fertility. And hence we argue that a fertility stall should rather refer to situations where fertility is high despite progress in socioeconomic development. And we find that there's actually very little overlap between countries with a conditional and unconditional fertility stalls. To do that, we use data from the demographic and health surveys, the multiple indicator cluster surveys, and the World Fertility Surveys, which are designed to collect demographic health and socioeconomic data from women of reproductive age, their children, and their households. In total, our sample of countries consists of 80 countries, 41 from Sub-Saharan Africa and 39 from non-Sub-Saharan Africa, and we restrict our sample to countries where we have at least 2 survey rounds, and we cover a period between 1975 and 2018 with in total of 369 surveys. To measure a country's fertility level, we use the total fertility rate, which is the most widely used measure of a country's period fertility. And to calculate the TFR by country and survey year, we use the information on retrospective birth histories of women aged 15 to 49 in the DHS mix and world fertility data. In this study, 3 different definitions of fertility stalls are used that have previously been proposed in the literature. Here we use a country, or the first one measures a country as stalling only if the decline in fertility has stopped, which means that the total fertility in one survey is at least as high as total fertility in the previous survey. The second definition classifies fertility as stalling if the annual fertility decline is smaller than 0.05 children born between 2 consecutive surveys. And the third definition proposed by Bongartz defines countries as stalling if there is no statistically significant acceleration in the pace of fertility decline. This definition, however, requires at least 3 or more surveys. And then in the second step, we propose our measure of a conditional fertility stall. We start from the assumption that a fertility decline does not start randomly, but typically is initiated by several structural changes. And here we consider 3 forces to be particularly important: child mortality, female education, and income. And moreover, we assume that once a fertility transition has started, it can only further continue if there's progress in these fundamental forces. Hence, our second contribution is the concept of conditional fertility stall, which identifies a stall if a higher fertility decline would be expected given observed changes in child mortality, female education, and income. And we do this by regressing the total fertility rate on under 5 mortality, female education, and GDP per capita. And then using these estimated coefficient, we can predict for each country and survey year the total fertility rate. Subtracting this prediction from the actual observed total fertility rates in that same year yields a residual. And we argue that a large positive residual indicates that a given country in a given year has a fertility level significantly higher than what fundamentals actually would predict. And we define country to be in a stall if the residual is larger than 0.5 children and larger than 20% of the predicted fertility. To come to the results, the table shows the total fertility rate across periods and regions. 2 things are worth noting. First, fertility has decreased over time, both in Africa and non-Africa. And second, fertility in Sub-Saharan Africa is still at a much larger level than in other low-income or middle-income countries. And looking at the pace of the reduction across periods and regions, we see that fertility in sub-Saharan Africa has been falling at a slower pace than in other regions of the world before 2010. Hence, all these studies concerning talking about fertility stalls in sub-Saharan Africa, especially those who have been published shortly before 2010. However, fertility decline in sub-Saharan Africa has been much faster between 2010 and 2016, and also compared to non-African countries. The next figure shows the number of countries that experienced a long-lasting unconditional fertility stall across the three different definitions of a stall. And looking at the orange bars, these are countries that experienced a long-lasting fertility stall across several periods, across different definitions. We see that the number of countries vary greatly depending on the definition, and this raises the question as to whether one should be concerned about temporary fertility stalls or only about long-lasting fertility stalls. Okay, and then coming to our regression results, the table shows the results of the regression of total fertility on mortality, education, and income. And the dummy for sub-Saharan Africa in column 1 suggests that countries in sub-Saharan Africa have on average 1.7 children more than in other regions of the world. Income, mortality, and education have the expected strong association with fertility, and controlling for income, mortality, and women's education, we see that the under 5 mortality rate leads to the largest reduction of the sub-Saharan African dummy. Hence, child mortality explains a huge part of the differences between infertility between sub-Saharan Africa and non-sub-Saharan African countries. So looking at the residuals based on the regression models, we calculated the residual for each country and survey year, which provides us with a number of children that are not explained by child mortality, mother's education, and income, and applying the definition of a conditional fertility stall, so more than 0.5 children, more than 20% of predicted TFR, we see that 13 countries actually are identified to be in a fertility stall for the most recent available survey year. Among these are Kyrgyzstan, Egypt, Mali, Uganda, Yemen, Zambia, Namibia, Nigeria, and Sudan. And we can also use the residuals to evaluate which countries have been showing higher fertility levels than predicted over an extended period of time. So the figure shows the residuals as examples for Uganda, Kyrgyzstan, Mali, and Niger. And interestingly, these countries substantially overlap with the countries we have identified to be facing a fertility stall for the latest survey. And to conclude, our analysis suggests on the one hand that in many cases, the stagnation in fertility transition can be explained by a stagnation of economic development. On the other hand, it shows that many countries with fertility declines even show faster declines given their socioeconomic environment in which that happens. And furthermore, there's only very little overlap between conditional and unconditional definitions of stalls, and the consensus that all that is needed for the demographic transition to remain on track is a reduction in mortality, education, and economic growth is put into question. Okay, I'm going to stop here, and thank you very much, and I'm looking forward to the discussion.
Thank you so much. That was a very well-paced and very clear, wonderful presentation. I don't know how many times you had to rerun the recording to get it so perfect, but anyway, we do appreciate it. Let's move on then to the second paper. We have Roland Kogu, now looking at, we're now taking a historical look. We've just been given a very lovely empirical look at the more contemporary stuff. Let's dive into the colonial origins of fertility. Roland, over to you.
Can I say something, Maury? The video was recorded by Marie-Christelle Mabu, who is a co-author on the paper. Thank you.
Thank you very much for that input. Important.
Good morning, everyone, and thank you for this opportunity to share our work with you. The paper that I'm presenting today is the joint work with Professor David Kenning and Professor Roland Pongu. In this paper, we are examining how colonial reproductive laws and market incentives interact to affect long-term fertility behavior. This study is motivated by a concern raised by policymakers who argue that the research agenda analyzing the long-term economic impact of history is of little relevance for policy making because history cannot be changed. In the paper, we acknowledge the fact that this history cannot be changed, but we ask the question of whether market incentives can mitigate the long-term impact of historical shocks. We address this broad question in this paper by focusing on the effect of colonial institutions on fertility. An ideal setting for our study is Sub-Saharan Africa, and this is for many good reasons. Africa is the region of the world with the highest fertility rate. An average woman in Africa has 4.8 children, which is the double of the world average. At the same time, fertility rates vary significantly across African countries. Especially, we observe wide gap between former British and French colonies. And in the economic growth theory literature, these variations are explained by differences in geographical factors, culture, institutional endowments. However, little is known about whether and how historical political institutions affect reproductive behavior. More importantly, the literature remains very quiet about whether the effects of these historical institutions can be modified by certain policy interventions. Our goal in this paper is to fill these important gaps in the literature, and to achieve this goal, we do specifically three things in the paper. First, we study the long-term causal impact of British versus French colonization on reproductive behavior in Africa. And we focus on British and French colonization because France and Great Britain were the major colonizer in Africa, and they brought with them two different types of institutions relevant for economic development and reproductive behavior. Especially, British and French had very different population policies. France had a pro-natalist policy that prohibited the use of contraceptive, while the British had a more liberal culture of reproductive rights. These differences has led to an early introduction and democratization of modern methods of birth control in former African British colonies compared to French colonies. And some of the outcomes that we look at in the paper include the level and timing of fertility, sexual behavior, and marriage. Second, in the paper, we test whether market incentives can mitigate the long-term effect of colonial origins. We analyze heterogeneity in the fertility effect of colonial origins by market access. The rationale for this study is that high market access is linked to increased female labor participation, which in turn increases the opportunity cost of childbearing. And we'll argue that if the market effect dominates the colonial effect of fertility, then we should expect the fertility effect of colonial institutions to be smaller in areas with higher market access. Finally, we also explore the nature of the mechanism that explain the average and the heterogeneous effect of colonial origins in fertility behavior. The mechanism is informed by the theoretical literature on the drivers of fertility and demographic transition. According to this literature, there are two types of determinants of fertility behavior. There are direct or proximate determinants, such as the use of modern method of birth control. We have distal or indirect mechanisms such as education, income, and child mortality. And we'll argue that there are features in colonial population policies and colonial governance rules that affect those direct and indirect determinants of fertility. But before I present the empirical result, I would like to show you a few interesting facts about fertility in former British and French colonies. This figure shows differences in fertility rate between former French colonies and former British colonies since 1916. It shows that since the 70s, fertility rates have been lowered among Anglophone women compared to Francophone women. And this fact matters because scholars and politicians believe that the poor economic consequences of African countries are partly explained by the high fertility rates. In fact, what is interesting is that there is still a debate about the real causes of high fertility rates in Africa, and this whole debate was the subject of a controversial debate among policymakers. During the G20 summit, the French President Emmanuel Macron said, "The challenge of Africa, it is civilizational today. What are the problems in Africa? Failed state, the complex demographic transition, which is one of the main challenges facing Africa." And he added, "When countries still have 7 to 8 children per woman, you can decide to spend billions of euros, you will not stabilize anything." So for the French president, high fertility makes poverty reduction less likely. But more importantly, he attributed Africa's high fertility rates to traditions and did not recognize any role for colonial policies. Of course, as you can imagine, his claim started a controversial debate in African countries. But this whole debate was not based on any strong evidence. And in this paper, we show that even after controlling for pre-colonial ethnic characteristics, including African traditions and cultures, fertility differences persist between former French and British colonies. So now let's talk about the data and identification strategy. In this paper, we rely on several sources of data. We use the Demographic and Health Survey to gather information about the fertility history of women of reproductive age. And we match this individual level data with historical data on ancestral ethnic groups in Africa coming from the George Murdoch ethnographic map. We also use georeference panel data on roads from the World Bank and panel data on urban population to construct our measures of market access. We use this data set to implement our identification strategy that relies on the Scramble for Africa. The Scramble for Africa has led to the arbitrary division of ancestral ethnic homeland across British and French colonies. And in the paper, we provide many facts and evidence that corroborate the randomness of these historical events. So this is the equation that we estimate using the regression discontinuity design. Here we regress fertility outcome on an indicator for whether a woman lives in an area colonized by the British. We include a second order RG polynomial in distance. This is the common way to for a regression discontinuity approach. But we also include in ethnic homeland fixed effect in order to be able to compare individual falling within the same ethnic homeland individual across the border. Concretely, our identification strategy is summarized by this map here, where we have the Ewe ethnic group divided across former British and French area. It is across former French Togo and former British Ghana. And our analysis, what we do is that we compare women living in the Ewe group and on each side of the Ghana-Togo border. So what do we find using this approach? Our main result is summarized by this RG graph. And here we draw on the x-axis our running variable measured by distance to the British-French border, with the negative value falling in French area while the positive value falls in British area. And as you can see here, the jump at the border indicate that women in former British colonies have lower fertility compared to Francophone women. And these results are confirmed in the regression tables available also in the paper. And the result here we can see that women in former British colonies have on average 0.3 fewer children. And these results are robust across several specifications, across different bandwidth. We also find a similar result for the other outcomes. Especially, we find that Anglophone women are more likely to delay initiation of sexual activity and childbearing, and they are less likely to marry before age 18. Now, I would like to talk about the effect, the heterogeneous effect of colonial origins on fertility. So we analyze the heterogeneity by market access. The main hypothesis is that if the market effect dominates the colonial effect, then the effect of British colonization should be smaller in areas with high market access relative to areas with low market access. And we empirically test for this heterogeneity by using two types of measures of accessibility to markets. We have a measure of access to international markets, which are proximity to sea, travel time to international ports, and measures of access to domestic markets, which are a network-based measure of connection proposed by Donaldson and Hornberg, and travel time to major cities. We first estimate the main regression discontinuity equation that I showed previously separately in areas far from the sea and areas close to sea. Here, areas close to sea are areas whose distance to the coast is below the median value of the distance distribution, and areas far from the sea are areas whose distance to the coast is above the median value of the distance distribution. And as you can see from this graph, clearly what we see is that in areas close to the sea, there is no significant differences in fertility between Anglophone and Francophone women. But in areas that are far from the sea, that is area with low market access, there's significant difference between Francophone and Anglophone women. Here also, the results are confirmed in the regression tables that are available in the paper. Different specification, which is given by this equation. In this specification, we regress fertility on British colonization, market access, and an interaction term between the two variables. And we control for all the other variables as in the baseline equation that I shown at the beginning. And what we find is that basically we find the same result. If you look at panel A in this table, for example, the coefficient on British colonization is small and not significant. What that means is that the effect of colonial origins in areas that are close to the market is very small. But when you go far from the market, if you look at the integration term between British and market access, we have we can see that the interaction terms are negative and highly significant, which means that the effect of British colonization is operating only in areas that do not have high access to the market. And this result confirms the result in the RG graph that I shown previously. Now let's talk briefly about the mechanism. Again, the mechanism is informed by the theoretical literature on the drivers of fertility and demographic transition. We find strong evidence for contraceptive use. In fact, the British friend gap in contraceptive use is more pronounced in areas with low market access, as you can see in this table on the interaction term, which is, this result is consistent with the fact that the British friend gap in the number of children is not pronounced in areas with low market access. Then on female education, we find weak evidence for female education. The heterogeneous effect of colonial origins on education are not consistent with the fertility effect of colonial origins. What we find is that British colonization positively affected female education, but the difference is more pronounced in areas with high market access, which is in contrast to the heterogeneous effect of British colonization on fertility. We also find weak evidence for child mortality and income, but for the sake of the time, I will not show you these results that are available in the paper. So finally, to summarize, we examine the causal impact of colonial origins on fertility behavior and assess whether market incentives can address this effect. And we find that women in former British colonies have fewer children. They are more likely to delay sex and marriage. However, we find that these effects are much smaller in areas where market access is high. We also explore the mechanisms, and we find that the fertility effect of colonial origins is mainly present in areas far from the sea. We find strong evidence from the use of modern method of birth control, but with to moderate evidence for female education, child mortality, and household income. This paper is also highlighting for the first time the heterogeneous nature of the colonial origins of comparative fertility behavior and economic development in Africa. And taken together, our results imply that positive exogenous market incentives can break the bound of historical determinism. Thank you.
Thank you so much. That was also a wonderful presentation. So let's move right along then to our third and final paper, because for those who arrived late, Leticia Martoletto is not joining us today. And so we'll move to Joshua Wilde, who's going to explain how missing men lead to missing women. Thank you, Joshua.
Hi, my name is Joshua Wilde, and today I'm going to be talking about my research on missing women and the natural sex ratio at birth. So in this figure, we see sex ratios at birth for a set of 12 countries over the last 60 years. So there's two striking features to this figure. First off is before 1970, sex ratios at birth within any given country seem to be relatively constant. In addition, after 1970, for these 12 countries, we see an increase in the sex ratio at birth, supposedly because of advances in ultrasound technology, which allowed for the easier identification of the sex of the child and allowing for easier abortion of children that were of a gender that was less preferred, in this case, females. So getting this natural sex ratio at birth correct is vital in order to accurately estimate the number of missing women. There has been a large literature for literally centuries trying to figure out what determines the natural sex ratio at birth. And while there was a large number of determinants hypothesized, the general consensus today is that sex ratios at birth naturally are a biological constant at about 105 males per 100 females. There are some variation. Mostly we have observed differences in different racial groups. So for example, we see that in Africa, sex ratios at birth are about 102 per 100 females. And in Asia, they look to be about 108 per 100, even in countries where we think there is no son preference. Interestingly, we find the same patterns of sex ratio at birth by ethnic group, even in the United States, where we think no sex-selective abortion is happening. So for example, African Americans tend to have a natural sex ratio at birth of 102. And Asian Americans, even those who are second generation, tend to have a natural sex ratio at birth of about 108. However, when you look at these sex ratios at birth and you simply plot them against income, they line up very well with the underlying income of this socioeconomic group. So one thing that I'm proposing in this paper is that perhaps it's not that there are genetic differences between these different racial groups, but perhaps it's something that is more of a social determinant, such as income or socioeconomic status. In addition, if we look across the world, we find that countries that are of higher income tend to have higher sex ratios at birth than countries which are low income. Now, it should be noted that this figure here actually omits countries where we think that there is son preference. So in the absence of son preference, we still find differences in sex ratios of birth across countries. The traditional explanation of this has been, well, Africans genetically have lower sex ratios of birth, and there's a lot of poor countries in Africa, and white people genetically have higher sex ratios of birth, and countries where there's lots of white people tend to be richer. However, recently there has been some challenges beyond the ones that I just described, to this consensus that sex ratios at birth are a biological constant at 105, which is this ratio on what's called the fragile male hypothesis. So this hypothesis generally says that in the presence of maternal stress, there are conception or a fetus is more likely to be spontaneously terminated by a woman. And the terminations are primarily concentrated among males rather than female fetuses. Therefore, 9 months after some sort of traumatic or stressful event for the mother, we should see a skewing of the sex ratios towards more females rather than more males. So there's been a large number of papers that have looked at this, but it is still a fairly new idea in the biological literature, and not everyone is sold on it. And at the same time, it goes against this long-standing hypothesis in demography that sex ratios at birth are a biological constant. So how come people think that they're a biological constant? Well, if you go within a country or even across countries and you run a simple regression where you have a bunch of births, as the dependent variable, you have the sex of the child. And for the independent variable, you have any number of indicators that could be correlated with maternal stress, such as parity, birth interval, age, or others. There tend to be no statistically significant coefficients. All the coefficients are small and close to zero and not statistically significant. So in this research, I'm going to point out two problems with this literature, one that's fairly simple to solve and another one that's more complex. So a lot of the literature that has pointed out that there's no effect actually has relatively small sample sizes and are underpowered. So recent work by Gelman and Bongartz has showed that in order to detect even a moderate amount of change in the natural sex ratio, you need over 1 million observations. And most of the studies that establish this fact have much less than 1 million observations. So the more nuanced problem is that if this fragile male hypothesis is true, that means that there is going to be an induced correlation between maleness and maternal stress, because now we're saying that stress not only causes miscarriages, but also causes the children that end up being observed and born tend to be more female as well. So this induced correlation may be skewing estimates of the femininity of births more towards males, the more stressed the mother is at birth, which if we currently observe no effect in the presence of maternal stress, it could be that there is a strong effect. We just don't observe it because this bias is overcoming the observed effect of maternal stress. So specifically, we have an econometric specification, which is very similar to what has been done before. We regress the probability as indicated by a 0-1 for whether the child is male or female as the dependent variable. And as the independent variables, we have a range of non-parametric estimates or indicator variables for age, birth order, birth interval, as well as some other controls. But what we do that's different from the rest of the literature is we now introduce a woman fixed effect. So for example, if you think that high birth order or a woman who has lots of children, the later children, the mother is going to be more stressed during their pregnancy because she already had a whole bunch of children. If a woman is just generally healthier, she has a large alpha, then she is more likely to be able to conceive lots of children and have higher birth orders. But she is also more likely to have more males, because as a healthier woman, she'll be more likely to carry a male to term relative to a woman who is less healthy and will have the males terminate at higher rates. So this is going to induce a correlation between birth order in our regression and maleness. So to run these regressions, we want to test this over a large number of countries where there is no assumed sex preference. So we're going to look at Latin America, Sub-Saharan Africa, the United States, and Scandinavia with this very detailed register data as well. This figure shows you the results of parity. So it's that regression on the fraction male by parity, where the parity is an indicator variable for first birth, second birth, third birth. The red line is the traditional estimate. Oh, and this is, by the way, this is for Sweden using the register data. So the traditional estimate is that sex ratios at birth are 105 and it doesn't vary by parity. That's the red line without the woman fixed effects that we introduce. Once we introduce this woman fixed effect, we see that the gradient starts to become negative. So the higher the birth order, the higher the proportion female. And these differences are quite large. So the first birth we estimate, rather than being 105, it should be more like 107. And by the time you get to the fifth birth, it's not male biased births, it's actually almost exactly parity, or even slightly female biased. And all of these differences are statistically significant at the 1% level. So we do this for Sweden, but we want to test this for other regions in the world. So this slide, if you compare the results for Sweden with the previous slide, they're the exact same. Now we're comparing the results I just showed you with the other regions of the world, and we find the exact same pattern with all the other regions of the world, which again is contrary to what the literature has supposed so far. So whether you're in Sub-Saharan Africa, Latin America, the United States, Sweden, we all see increased birth femininity with parity, which is consistent with this fragile male hypothesis and also consistent with this theoretical need to have a woman fixed effect in the regression. So up to this point, this might be interesting for a demographer. So why do we care about this in this PopPov space where we care about the developing world? Well, again, it goes back to that question of missing women. If my hypothesis is correct, that maternal stress actually changes the natural sex ratio at birth that you should observe in the absence of sex-selective abortion, then by controlling for it, we can get better estimates of missing women. And specifically, what I'm showing is that in places that are poor, where women have more births, where women are younger when they give birth, and when there's shorter birth intervals between each birth, the natural sex ratio in those places should actually be much lower than we observe in the United States. So to take the sex ratio at birth of 105 as a biological constant and apply that to India and Africa and China actually is going to underestimate the amount of missing women. So to show this, I ran a counterfactual for India. So in the 2015 Bongart's paper, which calculates missing women, they assume that the sex ratio at birth in India is about 105.9, and that's represented here by the green line. The black line represents the sex ratio at birth that was actually observed in India over the past 50 years or so. And so what Bongart's et al. Do is they take the black line, subtract the green line, and say the resulting gap is missing women at birth. However, I take my estimates from the United States of parity, birth order, and birth interval, and I apply those to India, and I show that the sex ratio, the natural sex ratio of birth, should actually be lower by 1 to 2 males per 100 females. So now the true number of missing women should actually be the black line minus the blue line, not the black line minus the green line, which is significantly larger. When I run the numbers, I find that this miscalculation of the natural sex ratio at birth actually is understating the number of missing women by 30 to 50%, which is fairly substantial. So I see that I'm out of time, so I'm going to stop here. Thank you for listening to my presentation, and I look forward to hearing comments and discussions after this.
Thank you so much. Another outstanding presentation. So now let's take the formal discussion where the presenters are each going to comment on one of the papers in the session. With Letitia's falling out, we're short of some discussion on Joshua's paper, but we have an amazing group of attendees here, and so we're relying on you. And Jocelyn will say something as well after we finish. So let's start with Joshua commenting on the first paper, if you don't mind. Thank you.
Sorry, I was having a hard time unmuting myself. One moment.
We can hear you.
Yes. Yes. Okay. So thanks again for asking me to discuss this paper. I liked this paper a lot. As mentioned in the instructions, I am going to talk about two strengths and two things that the authors might want to think about in the future. I think the main strengths of this paper is that, first off, it is talking about a question that is truly an innovation in this literature. They give a critique of something that people have done up to this point, and their critique is valid and interesting. So, you know, it's true that fertility stalls from socioeconomic stagnation should be considered as different from those which occur even in the absence of socioeconomic stagnation. The second thing I liked about this paper was that their results are actually quite interesting because they found very little overlap between the traditionally measured countries that have fertility stalls and their new, I guess, augmented or conditional set of countries with fertility stalls. So that was quite an interesting dichotomy to see. So I have two main things for the authors to consider. And before I say them, I'm very well aware that I think there's actually good arguments in the paper for why the authors do what they do. So even though I'm pointing out that these are perhaps bugs with the paper, they could also be considered features. Okay, so the first one is that their treatment of fertility, mortality, income, and education is very simplistic. So they just have a linear regression and they predict the expected value of fertility in a certain country given just this linear association independently between these four variables. But we know that these relationships are very complex and very intricate, and they may differ in the short run and the long run. So just to give an example, I have a paper where I look at a bed net intervention in sub-Saharan Africa, and we find that as malaria falls, it actually leads to short-run increases in fertility because women are healthier and they're more able to conceive children. In addition, Ashraf et al. Found in a macro model that when you get rid of malaria, there's actually an expected short-run decline in income per capita because you save a bunch of kids, which adds more capitas. So the way that the authors are measuring these things, you could actually see that when something beneficial happens, like a fall in malaria or a fall in child mortality, you could actually have increases in the stall as they measure them, even though in reality, what's happening is, I guess, you know, they could be following their normal fertility transition, but there's just this induced stall as measured by their specification. The other one is they specifically omit a country fixed effect. And in the paper, they argue that this is the good thing to do because this variation, permanent variation across countries, is actually something they want to measure in the stall. However, I'm not quite 100% sold that this is the right way to go about it because there might just be some fixed, you know, characteristic of a country such as culture or government policy, which makes a fertility in one country just naturally higher. And even to the point that since they're measuring the stall as basically a residual, you could have a country that has very sharp fertility decline in a very short period of time,
But if the average fertility started higher than the surrounding countries that are similar to it, they could still say that that country is in a conditional stall, even in spite of very rapid fertility decline. So these are my 2 comments, and I'm looking forward to the discussion after this. Thank you.
Thank you so much, Joshua. Let's move on to the next discussant, please. It would now be Ken commenting on Roland's paper. Thanks.
Yes. Can you hear me?
Yes, perfectly.
Okay. Yeah. I also thanks for this nice presentation, and also thanks for organizing this session. And I think for a first session, it actually goes pretty well. So thanks a lot. And yeah, I really liked the paper, and so I did not prepare a slide, but I also followed the instruction. The paper studied the effect of colonial origins and access to markets on fertility in sub-Saharan Africa, and the authors find that actually a well-established access to markets can mitigate or overcome even the long-term impact of colonial institutions. 2 points that I liked. First, I liked their approach of actually analyzing long-term historical impacts or effects on current demographic trends in order to better understand why there are still some countries having relatively high total fertility rates. And in particular, I like that the authors combined a short-term and long-term perspective in order to explain variations in fertility across countries, and in particular because this allowed the authors to analyze, and I agree to that, a very important question of whether it is possible to mitigate any long-term effects of a country's colonial past. So my 2 questions or comments, overall, I think the paper is very advanced. One is more detailed, and so I was wondering why you did not include any young woman aged 15 to 18, because as early childbearing and early marriage is also a considerable phenomenon observed in sub-Saharan Africa. I was wondering whether including these women would alter your results. And then, since I'm also interested in explaining wanted and unwanted fertility, I need to ask, I think it would be very interesting to not only look at actual fertility, but also on the number of desired children and also the number of unwanted children. I think your approach could actually contribute a lot to understand these 2 variables a little bit better. Okay. Thanks a lot. I'm looking forward to your answers and to the general discussion.
Thank you very much for those comments. And so I'm presuming that that Roland prepared some comments for Letitia, but if, with your permission, Roland, I would ask that we table those and we email them to her, but we don't present them here. We have such an amazing group of attendees here, and please, attendees, you can put up your hand if you want to say something from the floor. I am going to, there is one question there already. Jocelyn will pick this up. She might also offer some comments on Joshua's paper. So Joss, over to you.
Yeah, hi. Thanks, Murray. Thanks, everyone. This is such a great session. It's the topic of fertility is one that I'm so interested in, and I have to admit that I know a lot of these papers and the authors. I just wanted to offer a little bit of discussion for Josh's paper so that he has a little bit of that feedback. So the overall aim seemed that it was finding the natural sex ratio of girls and boys. And then also then the secondary aim then was to count the real number of missing women. And so I commented it in our chat that we have for the panelists. So Josh already saw it and he responded, but I was just asking that to have a little bit more of the literature. So Ken did a really nice background on all of the approaches that they had been used before for looking at the stall of fertility. And this seems like a numeric exercise where it would be really valuable to see what have others done before and why is your method superior to that. Then using the US data to analyze these other ethnicities and what's going on, say with the African Americans or with Asian background, that's really useful. But I always feel like you have to be super careful doing that because as an immigrant, I never like hearing this, but that we tend to take with us the cultural norms from our homeland into our newfound country, and we keep the cultural norms of that time. So now being an immigrant of 15 years in the US, I'm like, wow, I'm really outdated with my cultural norms. So it's hard to take an immigrant, even second generation, I would argue, and say that there's nothing sort of left over of the cultural norms. I think that even like they're more outdated and need to be really careful with that, using US data to kind of tease these things out, because the timing and the cultural norms are just going to be so different in many dimensions. And then you showed this correlation with income, and it was a little bit confusing because I was like, well, wasn't that about genetics? And then now it's about, you know, sort of the genetic predisposition to girls and boys, and now it's not. And then so I wondered about how does that all mix up? Because when you're richer, maybe you have, it doesn't matter if you have girls or boys, but when you're poorer, maybe, you know, the roles matter more, like the gendered roles of, you know, who helps around the house, who collects water. And I made a comment about parity on that as well, you know, so for higher parity households, maybe having more girls at later parities is useful. And then under a certain age, so maybe girls under the age of 10, they do lots of jobs around the house, and so they may be more useful, and having a constant supply of girls is more useful. So I think maybe just working a little bit on this sort of separation of the social versus the genetic would really help the paper, I think. Okay, they're my comments for Josh. And then do you want me to, Murray, do you want people to respond to each of the discussions, or do you want me to go over to the questions that were coming up?
Yes, let's just take a few more questions and wrap them in, and and then people can put up their hands as well from the attendees if they want to input. Yeah. And then we'll leave. So let's take 5 minutes of that, and then we'll allow people to respond. Thanks.
Sorry, 5 minutes for what? Me summarizing the questions? Sorry. I find the double tasking really hard because I'm like reading and then I forgot to listen to you. So that's a yes to summarizing the questions, I think. So, so I encourage everybody to put their questions in the question and answer. We have a really nice sized session here. There's about 20 of us here. So I really encourage you to put your questions in here, and we've had 3 really nice papers that all relate to each other. So please put your questions in here, and we can and get them into the discussion. So maybe I'll flick over to a question that was for Ken's paper, and then so from Tom, and Tom said that there was a paper from Schumacher and Bokia a few years back, carefully showed that fertility stalls are most often found in large African cities. And to some extent, this may be caused by the urban-rural migration, yet this is strange. cities are where most schools and economic growth is found, and their study also showed fairly high fertility preferences in large cities. Did you try to separate out urban, rural, and would your work offer explanation for this finding? So Ken, I see you've responded a little bit to that, but maybe we can bring it into the sort of the verbal chit chat a bit later on. And then Josh, you had a question in the question answer. And then, so this is from Jessie, super interesting presentation, thank you. I think you said you constructed the predicted sex ratio for India by using data on parity and some other variables describing a woman's fertility history. But you didn't mention age. So wanting to put that in there. And do you know the set of variables you used is sufficient? Do we know that the set of variables you used is sufficient to capture the individual level variation in the probability of having a male versus female? So maybe that's in the fixed effects model there. And then in other words, what data would you need to do your adjustment correctly? And I think that overlaps with my comment as well of like, well, what did others do and what did they include it? And then tell us a little bit more about why your method is robust. So they're the two big comments we've got in the chat.
Last
in the
chance,
question answer.
last chance from this amazing group of attendees. Just put up your hands if you want to say something, and then we'll turn it back. Tom, please.
Great, Tom. Not Murray, Paul, are you able to let Tom in to speak verbally?
Yeah, Tom's become a panelist.
Great, go Tom.
Over to you, Tom. Just turn on the usual
unmute
style.
yourself. There you go.
My camera's not working, so I'll just
No, I don't think anyone's would. Anyway, go for it.
Okay, this is more of a comment. Years ago, 2002, we published a paper on sub-Saharan Africa on the determinants of first union and first birth among women. So it's related to what you're doing. We used every DHS data sample we had from that time. It was meso level. We defined zones, 450 zones above the cluster level, below the national level. And the two variables that came through consistently the strongest was, as you'd expect, women's education, measured both at the individual and meso level, and child mortality. Child mortality, infant child mortality is vastly more important than urban-rural residence, women's work, socioeconomic status, and other things. And we were very surprised by the strength of that effect. And I noticed that the first two papers mentioned those two variables. And I was wondering if perhaps we're not looking strong enough at infant child mortality as an important covariate and maybe determinant of fertility throughout sub-Saharan Africa.
Thank you. So I think we should give the presenters 2 minutes each to summarize and wrap up and respond. Thank you. And thanks, Josh, for your great comments and things.
Okay, should I start?
Please.
Okay, thanks, Joshua. I think you made two very valid comments. So maybe I can approach your comments by saying that, so we started the overall macro paper with aggregated data because we were unsatisfied with these definitions of stalls. And then we said, okay, let's look at this a little bit deeper and then try a very, very simplistic analysis. And that's why we just did this simple linear OLS. And exactly as you mentioned, by choice, did not include fixed effects. We also did include fixed effects, but then we decided, and we had a huge discussion about it, whether to include it or not. And at this point, we didn't want to include it because we didn't want to look at country-specific effects. We just wanted to look at education, GDP, and child mortality. And obviously this can be discussed and also maybe should be mentioned a little bit more prominent in the paper. But so the overall idea was, let's start with the macroeconomic paper and then let's do a microeconomic paper and look at all these details that might explain this very complex issue of determining total fertility rate. So in particular, we are now looking at structural change measured by wages, measured by female labor force participation, measured by electrification. So we combine all available DHS with all LSMS service we could find at the admin 1 level. So the same level, I guess Tom was just mentioned. And we are now looking at this in a little bit more disaggregated way. So that's why our overall aim was actually to come up with 2 papers. So the first paper should raise these questions, which we then can answer with the second paper. But one idea would also be to take this all together in one paper. So yeah, I totally agree with your points, and we are working on that. And maybe just one comment to Tom's comment. I totally agree. And we also looked at infant mortality and we saw a similar large effect. And then we simply decided to go with child mortality as a much more often used measure. But yeah, I totally agree that we should look at infant mortality much more often. And yes, thanks.
Thank you so much. Roland.
Yes. Thank you, Maury. Thank you, everyone, for attending. Ken, thanks very much for your comments on the paper. I agree that that looking at wanted and unwanted fertility is important, and this is something that we can try to do effectively. Now, why don't we look at women age 15 years old? It is simply because we have an outcome variable which is being married before age 18. And because of that outcome, we chose to look at women above 18, just because we wanted to allow for full exposure to marriage. Okay, so this is the only reason, but we could have done that, and if we do that, the result will not change. Thanks, Tom, for your question. We look at female education, and female education is an important outcome in our study. If we had limited the analysis to the average effect of colonial origins, then we would have concluded that female education is indeed a mechanism explaining the effect of colonial origins. But why? Because Anglophone women are much more educated than Francophone women. But when we look at the heterogeneous effect of colonial origins, we realize that the effects on education are not consistent with the effect on fertility. And this result is robust across different measures of market access. We get the same answer, which led us to conclude that education here is not a mechanism. As for infant mortality or child mortality, we do find some consistent effects. I mean, what I mean here is that the effect of colonial origins on child mortality is consistent with the heterogeneous effect on fertility. but the effects are sort of weak, you know, in terms of the magnitude and in terms of statistical stability. But we really find very, very strong effects and very consistent effects for contraception. And that's why we are arguing in the paper that contraception here is the main mechanism. We didn't find any effect for income because what is interesting here is that the fertility gap opened before the income gap between.
Roland, can we wrap up, please? Thank you.
Yeah, I'm done, More. Thank you.
Thank you very, very much.
Mm-hmm.
Okay, Joshua, please come in for a few minutes. And
Yes.
then we can move the discussion to the person-to-person, by the way. This is an advert. You can move across and log in on the portal, and then it's like a live Zoom session again where you can just interact. But Joshua, over to you.
Yes, I note that it's already 6:15, so I have 0 minutes to respond. But it seems like if I could summarize the comments that people had is what's the correct comparison group? Who should I be comparing to?
Right.
That's actually a really great question. And the correct answer is that there is none that exist. You know, I would want to look at India without sex selection, you know, and compare this hypothetical fictional India with this India that currently exists, but that other India doesn't also exist. Also, statistically, doing what I'm trying to do correctly 100% is a statistical impossibility, because usually what you'd want to do is have some sort of Heckman selection thing, because, you know, where you have something that determines the sex but not miscarriage, but those are determined by the exact same thing, right? A conception that's lost. So what we're trying to do with this fixed effect thing is basically try to minimize the bias that currently exists and show that when we minimize the bias, we actually get very different results. Therefore, if we could fully magically get rid of the bias, the results may be even bigger. So we've been looking at trying to, well, I'll wrap up now. We can talk more in the discussion, but we have various strategies to try to come up with better comparison groups rather than just using the US.
Yeah, exactly. And I mean, given that the fixed effect, like, it teases one, it raises, it's plausible with your case, right? So there's a lot that you can do that's innovative without finding a precise econometric thing. It's a very clever idea of your fixed effect. Anyway, it was a very clever session, and it was a wonderful session. Thank you all so much. The presenters will certainly be switching across to the person-to-person, and please join them there if you've got anything further you'd like to engage with them over. Thank you so much for a wonderful session.
Thank you.